So the prediction of radar cannot be performed with arbitrarily high accuracy due to the uncertainty of parameters. Okay, so some of the parameters that are discussed about that we have to take in these parameters: the performance of the radar, the technical needs for the radar procurement, and the system trade-off that must be considered when designing a new radar system, because some of the factors affecting the range, which can be the high accuracy and the nature of radar detection. Now we will study integration of radar pulses. Okay, so the number of pulses obtained from a point target by scanning a radar with an antenna bandwidth in degrees. So by pulse repetition rate, which can scan the rate theta, and the number of pulses will be fp theta b upon theta s, theta b as in beam width of the antenna. Okay, so the number of pulses and obtained from a target by scanning, so the antenna with an antenna, then beam width of an antenna will be considered as theta b, and the pulse repetition frequency will be considered as fp. So the number of pulses will be n is equals to fp theta b upon theta s. Okay, fp theta b upon theta, where theta s is a scan rate. Okay, so we can write the number of pulses n is equals to fp theta b, the theta s, the scanning rate, is equals to 6 omega r. Okay, where omega r is revolution per rate minute, rpm. Okay, rotating the radar which rotated at clockwise direction means it shows that it's covering a 360 degree. Okay, so we can write it 6 omega r, where omega r is equals to revolution per minute. Okay, the number of pulses obtained can be known as the pulse scanning rate. Okay, we can also known as the pulse scanning plane. Why we are doing integration? Integration is the process of adding all the radar echoes at the receiver of the target. Integration pulses is the process which adding all the radar echoes at receiver from a target. Okay, so it is the process which adding all the radar echoes at the receiver from a target. So it is the integration of the radar pulses. In the radar receiver, integration which is done before the second detector can be known as the coherent integration or the pre-detection integration. There is two types of integration. Okay, the first one is coherent integration and the second one is and the second one is non-coherent integration. The coherent integration means the integration which is done before the second detector is known as coherent integration, and non-coherent means the integration which is done after a second detector. Okay, so this is the coherent and non-coherent integration. The integration which is done after the second detector without the loss is known as non-coherent, or it is also known as the post-detection integration.